Okay, I still have to get used to this, to do this on time. There we are. Good evening. Um, third time, third ORM, or should we call it Object Mapper? As I said, I'm going to give you announced I will do an analysis on Dapper. Now, let me tell you a bit about Dapper first. It's basically the database access that's behind the Stack Overflow website, and they created it because at that time they were using LINQ to SQL, and that was performing poorly. So they built another small, lightweight tool that performs better. That means that Dapper is a lot smaller and has a lot less functionality than the ORMs that I discussed before. So Entity Framework and Hibernate, those are very big. Now, let me share my screen, and then I'll just show you a bit of a comparison that that's on a Learn Dapper website. So basically, all it does is maps queries to objects. So you're just writing plain SQL yourself. So there's no query generation, there's no caching. So it works very well in scenarios where you either do very simple updates or you do want to have quick data results without state. So the bigger ORMs are built to um, to manage state, cache results for performance. So because they manage state, they have to understand what has changed, what an updates need to look like. It does a lot of query generation, so it can generate fairly complex queries based on your object graph. Um, so it has a lot of expectations about how your database is designed. Dapper has none of that, and as they say here, it's basically an object mapper, and you don't even need to define uh, type maps as you often need to do in other ORMs where you have to say, okay, this field maps to this column. So it's a lot easier to use, and basically it's a big set of extension methods on top of ADO.NET, which led to some design decisions, and we'll see that when we go in there. For those who weren't here, I'm going to take a similar approach as I've done before, but I'm not going to go in depth with CodeScene. I will show you a few things, but because it's a much smaller code base, there's a little less to see there. So I'll repeat myself a bit when it comes to what I've done last week. So CodeScene analyzes your code base, but it takes into account also the time dimension. So it looks at the history for the commits, and it says, okay, we have hotspots. So what you see here is not all the files that are in the code base. It's the files that have been changing. As you can see, there's a SqlMapper that is basically big. So it's a big circle, and it has a lot of changes. So the analysis now is for the past year. It has had 15 commits. So if we click here, you see it's 7. So this is the file that changes the most, which makes sense if we'll dive into it. But you see that if I click the async file, that has logical coupling. So CodeScene detects which files change together in commits, for instance. So that could indicate a coupling issue. What's very interesting with CodeScene is that you can do an X-ray. I've done one already. So the X-ray goes a bit deeper. and it looks at the hotspots on a function level, and it will tell you how often it has changed, the size that it has, and the issues. I don't want to go too deep in explaining all the metrics that it has, but as you can see, a bumpy road is a form of complexity. It's explained as well. Most of the problems it identifies here are big functions and complexity. As you can see here as well, and there's various reasons for it. But this allows you to zoom in on the really problematic pieces of your code. We can open the file and look at the code as well. As you can see, it's a very big function. Has a lot of reflection in here as well, or emitting. So it's generating objects. So this will help you identify targets for refactoring. It also internally looks at which functions are often changing together and how similar are they. So is there potential duplication in your code? So if we look at here, you see that it's a function. The difference is mostly this has one generic type and this has 7. But as you can see, there's a lot of similarities. But that's also a challenge with generics is reducing duplication can be sometimes harder. It can actually serve, but when you have a lot of type arguments, then it can get a bit more difficult. So let's go back to the hotspots. So and refactoring targets goes a bit further. That combines the hotspots with a few other dimensions, as how many people are working on a file, what's the general quality level. So this here, the code, it says it's unhealthy. You can see here, there's one main author. You can also review, and here you can see more detailed, like, okay, these are the rules that are violated. It's a brain class, which is no surprise because it's very big. So CodeScene gives you an overall impression of where is the problem, where are the problematic areas in my code. It allows you to go in depth, but NDepend is another static analysis tool. And I will change my view, by the way, and the screen gets a bit bigger. And NDepend has a lot more rule sets, which makes it hard to often identify starting points, also because it misses the time dimension. Now, let's jump to NDepend first, and I'll show you the rule that does that. And then I'll zoom out a bit and explain a bit more about NDepend. Let me show you. So NDepend, I'll explain it briefly before I go into it. The rules in NDepend are based on a code query language, which is very powerful because it allows you to write your own rules, to validate your architecture, to make sure that people that are onboarded, they adhere to your design rules. So it prevents deterioration in your architecture, which CodeScene cannot really do. So CodeScene is really good in identifying targets and helping you refactor those, but it's not that good in sort of sustaining more structural rules in your code base. So let me show you the rules. The rule sets are basically stacked, and a rule, let me just open one quickly. You can flag a rule as being critical, and then there's a quality gate that says, okay, you have critical rules that are violated, So you could, for instance, not pass the CI. Well, this is all configurable. You can turn off rules, you can turn on rules, create your own rules, make them critical. And the issues that come out of rules that can have a severity, and the severity is based on the depth, so the amount of time it would take you to fix it. And the higher the depth, the higher the severity. So rules can have various or multiple issues with different severities. Compared to what I've seen in Entity Framework and Hibernate, this generates a lot less errors. It does not have any blocker or critical issues, which the other frameworks had, but it's also a lot smaller. Now, let me show you briefly why it's harder to identify code to fix. It's a bit easier in this code base because it's not that big, but sometimes like you can get hundreds of results in types to fix or issues to fix. So and then you have to question where to start. NDepend uses the breaking point as a priority, which is an estimate of it's a function on the depth and the annual interest. So the annual interest is an estimate of how much it will cost you if you don't address the depth, and the depth is how much time it costs you to pay off the depth, and the breaking point is the depth divided by the annual interest. So that's why you see it's less than a year before you have a return on investment. So you have earned back your debt. Now, these are estimates, so I think they can be off pretty much, but it can help you. But as I said, it lacks the time dimension. So code that is, for instance, not touched in ages has a lower priority of fixing. So that's why it's harder to identify types to fix in NDepend. Now, I want to go a bit more in depth with NDepend, where I didn't do it. Last week, I really zoomed in on the matrix, so the dependency structure matrix. I will use it now in the analysis as well, but not in the same way. So what's interesting to note is, let's use the hotspot that came from CodeScene, and let's see what that SqlMapper actually is. Now, if we look in, we can already have some hints if we look in the just in the source. So there's SqlMapper, and there's a lot of SqlMapper dot, and then another type name, and potentially another type name. And the SqlMapper is basically the entry point. As I said, it is built on extension methods. And the interesting thing to see, if we look back here in the hotspots, you could notice that although this is a refactoring target, there doesn't seem to be any logical coupling. Whereas if you have the async SqlMapper, then that all of a sudden has a lot of logical coupling, which makes sense because if we open that, you can see that this is basically a bunch of extension methods, all extension methods of the DB connection. As you can see, I mean, I can just scroll all the way down. It's maybe a bit hard for you to read, but it's all static extension methods. So basically, there's barely all the state that is there is built in a static fashion. So the SqlMapper itself, oh wait, I should show you this. This is a partial class of the SqlMapper, and that has, as a result, has that the analysis results are different here because NDepend does not analyze code, it analyzes the assemblies, which is the advantage that you can actually analyze assemblies that are not yours, where you might not have the code from. But the disadvantage is that it doesn't, it just sees one CQLMapper. Now, if you look at the dependency graph, I expanded this already. Well, it's basically hard to read, but this is the whole CQLMapper with all the shared state that are used by the extension methods and potentially other types. Though it's mostly the extension methods because it does have to keep some form of memory in regards to how the types are being mapped. Now, what's interesting is that, so what you see here is that the blue functions are the functions that are used by this function, and the green functions are the callers. So this, as you can see, is a sort of a pivotal function within the CQLMapper. And all the red arrows indicate cyclic dependencies, and NDepend says, okay, like cyclic dependencies are a cause for more spaghetti code and less maintainable code. So they make it very explicit here. And they also do that in the form of namespaces, but there are no namespaces here. But the idea is that namespaces are modules and are layered. Well, you can observe a form of layering here in the types, that the types on the left are mostly have incoming dependencies, and the types or on the right, sorry, the types on the right have mostly incoming dependencies, and the types on the left have more outgoing dependencies. Now, in NDepend, you also have a code metrics view, and I want to explain some of these metrics. I don't know how well you know are aware of different code metrics, so let me explain a few a bit more in depth than what I did last week. I did do this. So based on what we see here, so first of all, they have a strong named assembly, and which is just basically linking code. So this is almost the same. So what you see here is each square is a method. The size of the square is identified by the lines of code, and the color is based on this complexity metric. So the cyclomatic complexity, for if you're not aware, and what you also see in CodeScene, is basically the amount of different paths that you have in a function. So the more if statements, the more nesting, the more different paths you can have through a function, which makes it more complex. Now, there's a few other method level metrics. You can see how much methods are called from this method, or how much methods are calling it. So these are incoming and outgoing dependencies, and you also have that on the type level. And there you see that cyclomatic complexity for the type is very high because it's a lot of functions that are in there. But you also have the types used and the types using me. So here, if I do this, then you would expect that if we go back to the dependency graph, that the identity has, it's hard to see, I think. It could be that it's not seeing that because it's all in part of this type. Default type map. Yeah. So as you can, that's the thing. Let me open this code because open source declaration. So as you can see, this is a separate type. So I would expect that, but I can't actually show you because all these types. So at least it splits up the types, but they, as you can see, SqlMapper plus identity. So open that up. So it's an internal sealed clause within the SqlMapper. And it merges all of that into on a type level within a single type. So I wanted to show in terms of that I would expect this one to turn on with a brighter so in this case with red or purple because it has more users. Metric on the type level, which is the lack of cohesion methods, and I went into that last week as well, and this says how much reasons are there to change for a file. So I was expecting the SqlMapper to actually have lack of cohesion methods, but it's mostly extension methods. So apparently it's not the case, but there's another type here, the grid reader. So we can just open one of those declarations and then I can show you another way. To be honest, I'm a bit puzzled why some types are, because it's public. So the other identity was the internal. So I think that's the reason why it's interesting. Why some types show up here as separate types and others don't. Where were we? The type grid reader. So the grid reader has a set of private variables, and not all functions touch the same private variables. And for that reason, it says that it has a lack of cohesion. Now, I will see if I can how this will show up on the another tool, which is the dependency structure matrix, which is another representation of a graph. So let me open this and zoom in. Oh wait, so I get the whole SqlMapper again. Yeah, so this is hard. As you can see, it just merges it into one file. So I can't actually see, well, I can, but it's a bit hard, and I have to look it up. So that's what I noticed here, that the design decision that they made is to put everything in basically one big static class, which some subtypes which are serving that class makes an analysis very hard from the perspective of NDepend. I don't know the exact rationale, but a lot of the subtypes are using internals on the SqlMapper. Now, let me still see if I can explain this for you. I can't zoom out further. But what you can do with that matrix, and I showed it last week as well, you can try to triangulate it. It doesn't want to zoom out even further. Let me just see if I can, what happens if I do this. By the way, I don't think I'm going to make a full hour this time on this. What am I looking at right now? So this is the SqlMapper, but it's not in the dependency columns. Yeah. So here we go again. So what this triangulate function does, it will put the more frequently used types more to the bottom, and the functions that, or the pieces of the code that are more closely collaborating are often within squares. So here you can see that, for instance, the query row implementation, and these are functions that use the query row implementation, query first, query first. So you can see that there's certain functions, query row implementation, using other functions, but there's no other pieces. If you can, oh, there's a few here, but so that allows you to spot pieces in the code that are more cohesive. I think if you really want to see more of that, I explained it also in my previous stream, and that was a bit easy to explain here for the reason I said that the way it's built, it can be pretty hard to analyze in NDepend actually. So that's interesting, but because I haven't seen that before. So I want to dive a bit more into the code query rules, because I haven't really went through that, because it has a few things that where you can also use the queries, for instance, to spot differences over time. So if you run the analysis every time, then it will allow you to identify differences in the in what has been changed, for instance. So there is a set of rule that's called code diff summary. So before I went into the stream, I ran two analyses, one on version 2.0.1.3 and one on the latest, which is 2.1.4. So you could see now, for instance, the types that were removed since the baseline, which is the 2.0.1.3, types that where changes were made in the code, methods that have been added, methods that have been removed. So you could, for instance, identify breaking changes, but well, just plugging in a new library will probably also tell you that. But it will also allow you to put rules on regression, for instance. So you could say, I don't want a certain metric to degrade. So a certain code smell. So you don't want to make a large method larger, for instance, or you can write your own rules for that as well. So it's very powerful in sustaining the quality of your architecture compared to well, in a different way than what CodeScene does. CodeScene is really focused on the metrics, but less on certain specific details that you want. For instance, you could say, I want to write a rule, and you can even generate it. Let me just show you. So you can write a rule that generates a warning if a certain dependency exists. Basically, those kind of rules start with warn if, and it said, okay, if this type is using this type or this function, then I want you to trigger a warning. You can also do that on a namespace level. So it could help you prevent unwanted dependencies that are very easy to make nowadays with code completion and alt enter. It's hard to spot, and it's almost impossible to. It's not possible to sustain conventions by code reviews. It's not doable. It becomes too complex. But what I wanted to show is just a few simple ways how you could write rules, for instance, that help you get a bit more details. So, for instance, the SqlMapper here is very big, and there's dependencies on private fields. Now you can go into the dependency matrix and you see that there's private fields here. I can hover over them, and you can see it because they are more faded, so they're not as wide. But you could also say, okay, I just want to have a list of those. I mean, so I wrote the query for that, where you can say, okay, from just my code, I can explain you a bit how that works. Give me all the fields that are part of the CQLMapper and are not publicly visible. So then you can generate a list of the private fields, for instance. What you could also do is say, okay, from T in just my code.types, I want to see the extension points in this library. So let's for now assume that those extension points are interfaces. I say, okay, from just my code, give me all the type, where the type is an interface, and select that new T. So here you see that now I have the interfaces of that you can extend. So for instance, I think an interesting one is a type handler. I don't know why I cannot open the code in this case. My type handler. And you can implement that. There's some documentation. So it will help you. And I mean, you can say, okay, I want to have the extension points within a certain namespace, or I want to have something else. I can also say, if there's, just give me abstract types, probably this abstract. Funny enough, an interface is apparently also an abstract type, but there's an abstract type handler as well. Type handler T, which is an abstract class. So you can deduce from this that you can probably extend that to write your own type handlers, and type handlers help you initialize a type on a specific field, for instance. What else do we have? NDepend also has an API, and you can use the API to write your own programs with it. They have an example with a few power tools. Let me show a few power tools. Not all are working based on the license that I have, because some want to trigger new builds. But let's say I want to show trend values. Then I have to select this project. Oh, it doesn't give me anything. I think it was another one. The methods that are changed, I think. This one doesn't work. It wasn't. I couldn't get this one to work. But I'm looking for another one. Oh, here, for instance, the public API changes. Well, you have your queries for that as well. Oh, that doesn't work either. I have to figure out how this works. There was another one. Let's just try another one now. I haven't tried all of these. But these are using the NDepend API to do extra analysis. So apparently there's that code in 9 unused types and 13 unused methods. I think there's actually a query where you can actually just do it yourself. but this can very well be that. I mean, that's with libraries. There's public methods. They're not being called, so it's you don't really know if it's actually that code when you have an internal library or a piece of code. Then you can be a bit more certain on, especially when you're not using dynamic instantiation, but you can use attributes to flag those. So I said in the announcement that I wanted to do a bit of dynamic analysis, so you could generate diagrams. I thought I found a tool to do that, which is AppMap, because it was integrated. It was, I could install it in JetBrains Rider, but apparently they don't have .NET support because this is a very small library. I can go. There's less to go in depth with, also with the output. So it's harder for me to fill an hour right now. So I have to figure out still how to do that, because I think it can be very essential if you, or usable if you have other tools to understand the code during runtime. I don't have a Visual Studio version. In the past, you could generate sequence diagrams, for instance. So I'm still looking for that. So if anybody has suggestions, I'd love to hear about that. But right now, I'm still puzzling a bit how to do more better runtime analysis and get an overview how certain pieces of the code are collaborating. You can do that to a certain extent in the dependency graph. Here it's fairly easy to see, but you could, in a dependency graph, if you have less overview, say, okay, I just want to see this type with the callers and the callies. So who is calling me, which types are calling me, or unselect. So you can see it a bit better. The grid reader is mostly calling other pieces of code, but the SqlMapper is, there's a cyclic dependency here between these two types, which is probably because, well, we can look a bit deeper. So I will show you how you can analyze certain dependencies, because at one point you might need this to split up code. So here you can see which functions from the grid reader are using which functions in the SqlMapper, and which functions in, now I also have to look where's the SqlMapper, which functions in the SqlMapper are using the grid reader. It's the constructor. So the SqlMapper generates constructs a grid reader, and I wonder if it supplies itself. Yeah, as you can see, it supplies some information about itself. So that's probably why it can call back into certain SqlMapper functions, or because it's static code. I mean, we can just look at, for instance, this code. So it's very good at navigating. So we can open the code now and see if we can understand how it is using the SqlMapper. I suspect it might be because this is a private field. It's cache, get cache info here. So get cache info is a function on the SqlMapper. So that's how you see that, because it's I can navigate to it. That's how they share the code, because it's all static. This is their way to basically inject dependencies by essentially just having static methods on a high level type, and make these static methods accessible to other types by means of making them nested types. It's a design decision. but as I said, it makes it fairly hard to reason about sometimes and really understand the dependencies. It's all, even with this tool, it becomes hard now. A matrix can sometimes really help you with that. I mean, when you have separate types, heck, let me show you just a matrix on the assembly as a whole, so you better understand what it would look like if the types are not that um, fused together in in the same way. I just closed all of this. So here you can now see, based on a type level, who is using who, where you have cycles. So for instance, the Dapper, the CQLMapper Dapper row is calling as using a type descriptor and vice versa. And cycles are often, as I said, hard to refactor. I think I want to do an episode or a stream on refactoring some of these cycles, but I have to experiment with that. But here you can see in a different way than on the graph where the lower level types are. So for instance, here you see the type handler, which is used by many functions in the various types. And as you can see here, basically the CQLMapper is the entry point and is using all these other types, and that's why you see it here on this row as well. And the type handler, if we look at on the dependency graph, then you should also see that it should be somewhere more on the right. Here you see the type handler, you see. So you can deduce the layering from either a graph, but not always, and the dependency matrix can also help you do that. Now, as I said, I wanted to show some dynamic analysis. I didn't get to that. I want to keep it with this. So I think a conclusion that I can do after 3 weeks is that cycles are very, like, all the code that I analyze basically has cycles, some more than other. This is a smaller code base. It's hard if you don't have the tools. Let's just be honest, it's really hard to manage your dependencies in your code and your cycles and prevent that you get structural spaghetti between types, using other types, and that will reduce your maintenance over time. That is really something that CodeScene can't do. What I also noticed that extension methods will require you to make choices due to their static nature, and sometimes also because of the accessibility for IntelliSense. You don't want to split them up over types in various namespaces. So you have better locality for certain functions and higher cohesion, but that would then imply that you need to include many more namespaces. I think .NET nowadays have some facilities that you can make that your life easier when it comes to that, because you can do global usings, global implicit using. So I think that's from a framework design perspective, something that allows you to be a bit more flexible in how you split up your extension methods. Now, I have seen other static libraries like Fluent Assertions, which also uses a lot of extension methods, splits it up a bit more, but it has some static constructors and uses a few centralized, basically dependency management. So you can decompose your dependencies into separate types. So you have a form of dependency injection, but it's basically managed by a static object within your code base. But the trade-off of that is that you require extra code to manage that. Yeah, I wanna close it off with this. I'd love to hear your thoughts. Send me a DM. What's not clear? I'm going to look to do some refactoring actually using the tool, because so far I've only showed how to analyze it, how you could use it in a refactoring. But I think it would be cool to actually go into a code base and see how we can improve it based with the analysis tools that are at our disposal nowadays. Thanks for your time. I hope to see you next time. Good evening. Bye.